Nuclear chemistry is the study of radioactivity. It is an important part of science because it explains what is happening to the atoms during different stages of change. Even though when people think about radioactivity, they most likely think about bad things, it has actually changed the world in many ways for the better.
This just in. Why do atoms undergo radioactive decay? Unstable atoms undergo radioactive decay. For an atom to be unstable, the nuclei have to have a proton-neutron ratio that is too high or too low. They will keep decaying until the atom is stable. The nucleus wants to become stable and undergoes nuclear decay that releases radiation. We have just received news.
Compare and contrast the three types of nuclear processes. Decay is the process by which an unstable atomic nucleus loses energy by emitting radiation. In all three types, the nuclei emit radiation, but the nature of that radiation differs from one type of decay to another. There's alpha particle, beta particle, and gamma rays. Fission is when the nucleus of an atom splits into smaller pieces, a form of nuclear transmutation. The resulting fragments are not the same element as the original atom. They are releasing a large amount of energy in the process. Most commonly, this is done by firing a neutron at the nucleus of an atom. The energy of the neutron causes the target element to split into two or more elements that are lighter than the parent atom. This is the daughter atom. Heavy elements can do this. The natural form of radioactive decay is where elements break down on their own. Fusion is when two or more atomic nuclei come very close and then collide at very high speeds to join and form a new nucleus. Two hydrogen nuclei fuse to form a helium nucleus, and a neutron and a great deal of energy are also released. Light elements can do this.
We have just received word. Three types of radioactive decay and their processes. Alpha particles are positively charged. They have the least penetration power, which means they won't go past a fixed surface or skin, meaning it is the least dangerous to us, but can still be harmful. They are highly electrified helium atoms. They have 2 protons and 2 neutrons, a mass of 4, and an atomic number of 2. If they get into the human body, they can become very dangerous. Beta particles are negatively charged and are highly energetic electrons. Once it gets into the nucleus, neutrons divide into protons and electrons. It is an electron ejected from the nucleus at high speed. It can be stopped by aluminum. Gamma rays have no charge, and it is not a particle at all. It's an energy. It has no mass, and they're the most penetrating, which means that they're most dangerous to humans. It can be stopped by a very thick block of lead. Breaking news!
How to write a balanced nuclear equation. It is to balance reactions for mass and charge. It is the parent and daughter nucleus. The parent nucleus will turn into the new daughter nucleus added with the type of radioactive decay. One example is CO with 60 and 27 changing into nitrogen with 60 and 28 plus 0 and negative 1 for electron.
Now we're going to Ava with the latest news.
Explain the band of stability and how to predict what type of decay the unstable nucleus will go through.
When plotting the ratio of neutrons to protons, neutrons on the y-axis and protons on the x-axis, a line forms on the graph. One straight line, which is the 1-to-1 proton-neutron ratio, and one curved line. The band of stability shows the isotopes or the atoms that are stable. All the other atoms that are off the line are unstable. To predict the type of decay, the position of the element, atom, or isotope shows what type of decay will turn the element stable again. B positive to the right of the band of stability, B negative to the left of the band of stability, A, which means it's a lot higher than the band of stability, and gamma rays always are going to be with beta and alpha. Back to you, Ava, with more breaking news.
On how to explain the concept of half-life and how to calculate. The time taken for the radioactivity of a certain isotope to fall to half of the original value, or years, is a half-life. To calculate half-life when given the rate of decay and the quantity remaining after a measured period of time, the equation is n of t equals final quantity, n0 equals initial quantity. So n of t equals n0 and then in the parentheses you have 1 over 2 to the power of T over T. This just in. Compare the amount of energy released from a physical change with a chemical reaction to nuclear reaction. The identity of the substance is changing for nuclear, and as well the protons and neutrons react inside the nucleus. Elements transmute into other elements, and isotopes react differently, and they're independent of chemical combination. And the energy change is equal to 10 to the power of 8 J. And massive changes are also detectable, and it's E equals mc squared. And for physical, it's change in outside appearances, and physical is a change of form of substance.
Nuclear science can be used for many things. Some examples are to check what elements are harmful to humans, to produce weapons. They can also be used to make nuclear medicine to help doctors diagnose and treat patients. Example would be cancer. And they can identify elements that can create energy that is used in space.